Hi, everybody. We're going to start on the section for solving equations, and I'm going to go through just a little bit of an introduction about what we mean when we solve equations and why we do the opposite to both sides instead of simply filling in the blank. Hopefully, it won't be too involved, and we'll get started with how to actually just do it. But I'm going to start with J3, which is solving one-step linear equations. And then we'll take a look at it and see how it goes. Here we are. One-step linear equations should be coming up. Let's see what's going on. Come on. Hi. Come on. What's going on? Oh, man, it's not working. There we go. Now it's going. It did not want to go. There we are. All right. So here's the problem. Anyone, even a third grader or even possibly a second grader, could understand that we're looking for the value of n and we want to find out what number minus 2 is equal to 1. And most people are able to go, oh my God, 3 take away 2 is 1. Amazing. But that's not algebra. That is just filling in the blank. And what I mean by that, let me just fill this in. Oop, pen. There we go. This is not algebra. This is asking what value, and we're asking you to do find a value in your head. And this will work. It will actually give you the right answer. And of course, we know that 3 is the missing value. And so n is equal to 3. And I can remember very vividly thinking my math teacher is insane. She said that we're supposed to do this. N minus 2 equals 1. And we're supposed to do the opposite to both sides. It seemed like a ridiculous idea at the time. And I refused to do it. And of course, after a couple of weeks, I was failing and couldn't figure out why. So I'm going to tell you, you need to do the opposite to both sides. And I will explain in class and on other videos why this is so important. But basically what I've done is add 2 to both sides of my equation. This gives me n plus 0 is equal to 3. And that is the correct way to do this problem. Now for the rest, I'm not going to explain it quite so much. I'm just going to subtract 3 from both sides. But in my head, I'm going to think about this. I'm not going to ask myself what number needs to be added to 3 to get 19. I'm literally going to, in my head, subtract 3 from both sides. Minus 3 gives you 16. In this one, I'm going to subtract 2 from both sides, and I'm going to get 6. Now, here's one of the reasons why we do the addition or the subtraction on both sides, because a lot of people are not going to be able to figure out in their head what value of k subtract 11.93 gives you 2.07. But what they can do is this, 2.07. Notice that when I add decimals, I have to line up the decimals. Sorry, my handwriting isn't very neat this morning. I'm going to add 11.393 to both sides. Notice I tried to line up the decimals. This gives me 0. And k is by itself over here. And on this side, I have a 0 and I'll carry the 1, and a 0 and carry the 1. And we have 13, 14.00. Now I can just simply put 14. It works just fine. Hopefully it won't matter if I put the zeros or not, but I'm not going to put them. Now this time we have to do the opposite to both sides. And again, a lot of people are going to have trouble getting 12.64 out of that because it's not going to be obvious to them that 12.64 divided by 4 is equal to 3.16. But what they is going to be obvious is that I'm going to follow the rule, which is to do the opposite to both sides. This is division by 4, and the opposite means multiplying by 4. Now, I don't like using the x for multiplication. We usually use the x for a variable. So what I'm going to do is use parentheses. And a lot of people have trouble with knowing where to put the multiplying. The multiplication is in the numerator so that this 4, which is really 4 over 1, simplifies with the 4 to give me 1, not 0. Notice that I'm using 1 times d is d. If this was 0, it would give me 0. That's not correct. 4 times 3.16 is 12.64. If you want to do a multiplication, don't grab your calculator. Actually do it on the side. This time I'm actually going to put the x. That's 4, carry the 2. That's 4 with 2 more. That's 3 times 4 is 12. And we have 2 decimal places, which gives us 12.64. And that is our d. That is the value of our d. Now in this one, we're going to do the opposite to both sides. And again, we're going to divide. Now, again, a lot of people are not going to be able to divide by 2 in their head, but it doesn't matter. We're going to take 2r equals 13.42. And we're going to divide by 2 on both sides. Looks like we get 6.71 or something like that. This gives us ones, and r is equal to. Rather than doing it in my head or grabbing a calculator, go ahead and set it up. 2 goes into, never hurts to do a little review of division. Now, if the decimal was on the outside, I'd have to move it, but there's the decimals right there. The decimal goes straight up. 2 goes into 13 6 times, 1 remainder. Some people like to do the little subtraction there. We bring down the 4. 2 goes into 14 7 times, and we subtract. We don't put the 2 here. We bring the 2 down, and 2 goes into 2 1 time, and we get a 0 remainder, and we're all done. That is decimal division, and we get 6.71. This one, we're going to subtract 1 and get 8.6. Notice I did not do the fill in the blank. Very important, 8.6. In this one, I'm going to add the 2.67 to both sides. I'm just going to simplify this just a little bit. 6.64. I'm just going to add the 2.67 to both sides. I know I'm adding it to both sides. That is 9.31. I'm going to divide by 10 and get negative 5. I'm going to subtract 12 and get 44. I am subtracting 12 from both sides. I'm going to divide by negative 7. Here's a mistake that a lot of people make. They'll do this equals 70, and then they want to divide by 7 rather than negative 7. If you divide by 7, it's not wrong, it's just it won't be finished, because what will happen is I'm going to end up with negative 1v on this side, and on this side I'm going to end up with 10. So that's not what we're interested in. We want to know what the value of v is. So I want to get a positive v. In order for that to happen, I need to divide by a negative 7, which gives me my negative 10. I'm going to divide by 2 and get negative 31. I'm going to divide by 8 and get negative 11. I'm going to subtract 41 on both sides and get 3. Notice that the D is on the right side rather than the left, but it doesn't matter. Again, it doesn't make any difference which side you're on. This equation happens to be the same as this equation. And because if A is equal to B, then obviously B is equal to A, or the other way around. We're subtracting 41 from both sides and getting 3. We are going to add 993 to both sides. A lot of people are going to have trouble with that, so I'm going to go ahead and show this. T minus 993 equals negative 45. And again, they're going to grab their calculator, which is a really bad idea. The rule for integer addition says that if we have different signs, we have to look at the difference of these numbers, which is 948. And we want the sign of the larger because the 993 wins over the negative 45. Basically, I'm doing a thing called conjugation. So what I'm doing is I'm saying, well, 993 is really 948 plus 45. This 993 is this, and this positive 45 cancels out with that negative 45 and gives me 948. Now, some people are going to say, well, I subtract the numbers, or rather subtract the absolute values and look at the sign of the larger. Lots of ways to go. I prefer to use this methodology where in my head, I divide this 45 out and cancel it out. So 948. This time I'm going to multiply by negative 29. A lot of people are going to get negative 5 out of this, which it's not. This is a division, and I'm going to have to multiply by negative 29 on both sides. These cancel out and give me 1s, and I have j by itself is equal to 24 times 29. Lots of ways to do this multiplication. I'm just going to go ahead and do it on the side. Notice that I'm not putting the negative in until I'm finished. This is going to be 36, carry the 3, that's 21, that's a 0 and a 48. And we have a 696, but because it's a negative 29, I get a negative 696. Not because the 29 is larger, but because I'm multiplying a negative times a positive, which will always give me a negative no matter what. Negative 696. Now, one thing I recommend is to have a calculator just handy on the side, or maybe pull it up on your screen so that you have a calculator, but use it to check. Don't use it as a normal device every time. This time we're going to divide by 26 on both sides. 26W equals 312. I'm going to divide by 26. And I'll go ahead and do it on the side just to show how it works. 312. 26 goes into 31 once. We subtract and we get 52. 26 goes into 52 twice, and we're done. So W is equal to 12. We're going to multiply by 29 on both sides. So we're going to take 14 times 29. That is 6, carry the 3, that's 12, 0, 28, 406, I believe. And it is negative because, again, it doesn't matter which one is larger. It just, when you do multiplying integers, the sign is always negative if you have one negative. If you have two negatives and you multiply, you get a positive. That is negative 4, 6. Hopefully didn't have a brain fart and miss it. Let's see what's next. We're going, I like this one. We have a double negative here. y subtract -8 is equal to 661. This double negative says subtract a negative, which is the same as adding a positive. Hopefully you'll watch the video from the math video. What is the name of it? Can't remember anyway, he talks about this, and it's really good. Math Antics. So hopefully you'll watch the Math Antics video and really understand what's going on here. This double negative is really a positive, and this I have to subtract 8 in order to solve for y. So y is equal to 653, I believe. And we're done. 653. Finally. Took us a long time to get here. All right, and this time again, we've got this double negative, which is the same as 17.27. Oh, I said 27. Is equal to g plus 16. And so we're just going to subtract 16 from both sides. And in this particular case, you can do it in your head, and you get 1.27. One of the things you want to keep in mind is that when you do decimal subtraction, remember to put the zeros in and keep the decimals the same length. That is 1.27, or 1 27/100. We're going to multiply by -4. Shall we do it in our head? 12.84. It's going to be a negative. We're going to divide by 2, which is going to give us 8.7. I'm actually dividing by 2 on both sides. Yep. We're going to divide by 4, which is going to give us 3.4. 3.44. I'll do the division over here. 4b is equal to 13.76. We're dividing by 4 on both sides. If you want to do the division on the side, 4 goes into 13.76. Like I said, 3 point subtract, you get a 17, you go 4 times, you subtract the 16, you have a 1 6 left, which goes in 4 times, and you have a 0 remainder. So 3.44. Come on. Okay, we're going to divide by 3 on both sides. So 3 goes into 8.22. Let's see, it's going to go in 2.74 times. So 2.74. I'll do the division over here. 3h is equal to 8.22. Divide by 3. 3 goes into 8.22. For decimal division, decimal goes straight up, goes in twice. Subtract the 6, you get 22. Put in the 7, you get 21. You have a 12, and it goes in 4 times. That is 2.74. We're going to subtract 12.24 from both sides because this is addition. That is p plus 12.24 is equal to 16.74. We're going to subtract 12.24 from both sides. P is equal to 4 looks like 5. And we could put 4.50, same thing. We're going to subtract 5 from both sides. Now be careful. I've got a negative already. Negative 9.57 equals z plus 5. And we're going to subtract 5, which means I'm going to go further negative. That's one way to think of this. I like to use debt accumulates. We'll talk about that later. negative 14.57. Notice that I do have zeros on there. That is going to be further negative. Looks like I've got a couple more to go. Let's see. We are going to multiply by negative 4. So d over negative 4 equals negative 2.7. We're going to multiply by negative 4, which gives us d is equal to, we're going to multiply that. It's going to be 10.8, I believe. Good idea to do it on the side just to double check. I have a negative times a negative, which of course is a positive. That's 28, carry the 2, and that is 10. And we have one decimal place, which is 10.8. And our last one, let's see if we can keep from making a mistake today. We're going to multiply by 3 and get 10.5. I'm going to go ahead and write it out. It's always good to double check on your very last one. Kind of gets irritating when you miss the last one. The 3's cancel out to give me 1s. And 3 times 3 is 9, plus the 1.5 gives me 10.5. Basically what I was doing is taking the 3 and distributing it with the 3 plus the 0.5 and then adding them up. So that is 9 plus 1.5, which allowed me to do the problem in my head. And it looks like we're done. It took 20 minutes for me, which means that it's probably going to take you even longer, but it will be worth it. Do your practice, and I will see you back tomorrow. Bye. Oh, here we go. Stop recording.